Now, section 5.1 will study what markers are, and then interactive markers, both in RViz. So RViz lets you include markers, and markers can be different things. For example, this frame right here. This frame has an XYZ axis and might be useful to display the pose of an object with respect to a sensor. Sometimes you might be looking at a table, you might be looking at a cup, and you need to know the pose of that object. But with respect to what? Probably with respect to the sensor. And so this might be very useful to give you a belief or an idea of that pose. Another way that you could use markers is to display a reachable kinematic region. Well, take a look at this picture. So here you can see a plane covered by these markers. Now these markers are very different from the axes we saw before. Here we have some spheres. As we'll see in a second, markers can take different shapes: spheres, squares, triangles, lines, arrows, etc. You can have one of them, like a single line or arrow. You could have three of them together, like the frame we formed in our first picture, or you could have an array of them that cover a particular region. And so you could think, if you want to know where your robot arm can reach, remember you have limitations of the robot workspace, you have joint limits, and you have kinematic constraints. So you're not always clear what areas of the workspace one particular arm may be able to reach. You could compute the reachability of the robot and then display that using markers as in this picture. Another application example is what is called interactive markers. This is commonly used in Move It. So here, for example, you have two arms of the Baxter robot, and the orange or here yellow color might indicate where the robot is starting, or where it's finishing. The red color is where it's starting, and these markers allow you to click on them using a mouse. And here you have two kinds of interaction markers. You have translational interactive markers, and you have rotational markers. And so you could click on one of the arrows and move the hand in a straight line, or you could click on one of the rings and rotate the hand. Now these interactive markers here are connected to the end effector of the robot. So when you move the marker, you also compute the inverse kinematics of the robot to update the arm pose. And so this can be useful in interacting with the robot manually to move the arm. So these are some examples of markers. And how do markers work with RViz? Well, anytime that you want to display a marker, you need to add a marker display on RViz. You have marker displays, you have marker array displays, and you have interactive marker displays. Regardless of which of these three we add, we'll always see that there's something called the marker topic. And so in your C++ code, there will be a place where you select a topic for marker information to appear. So RViz is always interacting with data through the topics that we have from our nodes, and that's how RViz knows where stuff is. When we have a regular marker, we're going to use a message called visualization messages marker. Now let me show you an example of that one. these are the interactive markers. Let me open a screen here. Ross message show, visualization messages. As you can see, we have several for interactive markers, but we also have some for just marker like this. So when this opens, the first thing we're going to see is that we have a list of types. So for example, we can use markers that are arrows, cubes, spheres, cylinders, line strips, line lists, cube lists, etc. And those are later used with the marker type. We'll see an example very soon. Each marker can have an ID, just a label. It could be 0, 1, 2, 3, 4, 5, 6, and so on. Each marker will have a pose, needs a position and orientation. It'll need a scale, that is the size in the XYZ directions. It'll need a color, red, green, blue, and transparency. It'll need a duration. How long should this marker exist? The default is for a lifetime. It'll have this true or false on whether or not its frame is locked. And then this will be for different markers. Do I have one or an array of them? And if I do have an array of them, what is their XYZ positions and what is their colors? There's a few more pieces of information that we'll see in a second. Here is an example of what those markers might look like. The squares, the spheres, the cylinders, the lines, more squares, more spheres, cylinders, etc. So as I was mentioning, you have a header, you have the pose of the marker, a point XYZ, and then a quaternion. You have the type. You have something called the action, and this is whether you want to add a marker or delete a marker, or even delete all of them. The scale, the color, and some other information. So our first example with markers will create a plane of spherical balls. So we're going to be looking at the package example Arvis, this is not maker, marker, and then example Arvis marker.cpp. So if we do rosette, example Arvis marker, example Arvis marker.cpp, we'll be working with this code. Now I'm going to come back here in a second. Let's look at a summary of what's happening here. One thing we need to know is the way that we're going to interact with these markers for this plane is using a service. So we'll have the code will really set up the service server, as we indicate here, and we will do a manual client call. That client call will simply set the height of the plane. And then the server will be publishing the marker information out, and this is where Arvis will be reading the information. The first thing we're going to do is define or include information for the marker message and also for the service message. We will have the service callback, and this is going to basically set the plane and given the height. Then over in main, we'll of course initialize the node and we'll initialize the service server object. We'll create the markers and fill the information out, including the type, the action, the pose, the scale, the color, and the header. Once we've done that, we can then publish. And then at the end, in a different terminal, we will manually call the service client to set the height of the plane at which the markers should show. So let's return back to that code. And let's go to main first. So you'll see here's our initialization, here's our node handle, and here is a place where we're going to publish the marker information. So here we're using visualization messages marker. We have that in our header right here. This is important to define the marker. Okay, and this is going to be the topic where the information is published. Okay, now let's create our ROS message object, which is simply called marker. And then we'll also introduce this new type called geometry messages point. If you want to see what this looks like, we can just show it right here. And so as you can see, a point is defined as 3 elements, X, Y, and Z. This will always be useful if you want to show the position of an object. Let me close this window. Okay, so we have a point here. And then we are going to set up this service server to get information from the client and set the height. So we have a regular service server, and here we're going to work with this service topic, Arvis marker service. And it is in this callback where we are going to create, we're going to adjust the plane's height. Okay, so we take this marker and then we're going to initialize it. So let's look for this function. Sorry. Let me do that again. Oops. Init marker files. Here. So when we call this function, we input the marker here, passing by reference. We set the frame ID, we give it a stamp, we give it a namespace, we give it an ID, and here we can choose sphere or sphere list depending on if we want a single marker or a group of markers. So here in marker type, we use this definition coming from ROS, visualization messages marker sphere list. So types are generally defined in this way, and actions are similar. We need to say we want to add, but that definition comes from the class visualization messages marker add. Okay, and we have not yet set the position. We are going to be doing that later through the server, but if you wanted to, you could do that here, and then we'll set a default orientation with a quaternion 0001. Okay, here you can play with the scale. Maybe you can change these numbers and see how the size of the marker varies. You'll need to compile if you do that. But here we set them in each of the 3 directions at 0.02 meters or 2 centimeters. And then we have red color for the markers. And this A equal to 1 means no transparency. Okay, so here we have some default markers, but with no position yet. We'll have a desired C height. And now we want to define our plane. What are going to be the maximum and minimum limits along the X direction, the Y direction, and then a small difference in the interval between markers. How far do I want them to be? So this is spread across -1 meters to 1 meter, so for a total of 2 meters with a spacing of 10 centimeters. So we have this while loop, and then there's this flag G trigger that is going to come from the service. We'll go and take a look at that in a second. So once the service is triggered, we'll set this trigger to true, enter this if statement, return that flag to false, and we'll copy the height that we received, this global height that we received from the service, to this z desired. So here we can still access our marker object, have a new stamp, clear out the old points. So we have this method clear, which is typical in vector classes. And then for the desired height, which is coming right here, we will create that plane using 2 for loops, going from x min, or setting x, going from x min to x max, and then having this spacing in between. Okay, so once we've done that, then we can publish the marker information out to our desired topic. Now we still need this spin because this node is also the service server. So every time the client issues a call, we need to enter the callback of the service server. That one is all the way here at the top, and it uses this name, display service callback. From our second class, you'll remember that we have the request and the response. Okay, and so here we can access from the message simple float service message. Let me see if I can find that real quick. Ross message show. This one is example Arvis markers. Is it this one? Nope. Service here. Simple, sorry, I should have used Ross service message show. Example Arvis markers, simple float service message. And so you can see that the request is just a number, a float 32, and the response is this Boolean. Okay? So here we can extract the height and set it to the global variable that we created at the top of our program. Change the global trigger flag to true, and then set the response to true. Okay? So I'll close this for now, and then return back to our presentation. And we can see how this works. First, we set up our vis and the marker. Now, to do the marker, we'll need to do a couple of things. We set the fixed frame to world. We need to add a new display for a marker. And then, because this node is already running, we will be able to find our example marker topic. After we do this, then we can do the raw service call and issue a height as a float in order to show the plane. Let's take a look. Okay, so I have our vis over here. I'll close this window. My fixed frame is set to world. I won't worry about this one. I'll open my marker. If I click here on marker topic, I don't see anything, and that's because I haven't not run this node yet. So let's run example Arvis marker. Example Arvis marker. Now here I can find that topic. Okay, and I see that immediately this plane of spheres was created. So the initial height is set to 0, and that is where we display the plane. Now we can use this command raw service and list the call function, and then give this service topic, the Arvis marker service, If you don't remember that, we can always say raw service list. Let me see. And then we find our raw service topic here, Arvis marker service. We can also ask for information about that. And that tells us the node that created it, and also the service topic type or the service message, and the argument that it's expecting. So once I do that, I can issue my service client call in this way, and as soon as I press enter, I change the height of all markers to 1. Okay, so the real lesson here is, number 1, how do I define a marker? How do I publish the information? How does RVis interface with that topic? And then how could I potentially use a service to modify the properties of my markers? Let's look at a second example called a Triad display example. So if we want to draw a frame, what would we do? And here Triad means 3 or 3 lines. And in order to do this, the first thing that we would need to do is define an origin for that frame. After that, think of this frame as 3 independent lines. Each line would have its own origin, the location of its origin, the location of the tip, and thus the length. But also we need to define the orientation of that line. This line could have a fixed length, but it could be pointing in different directions. So orientation will also be important. And then we need to define the rest of the properties. What kind of marker type is it? Am I adding or deleting a marker? What's the scale and what's the color? After we do that, we can also publish the markers again. Now, I won't go to the CPP code right now, but you can do it at home by looking at the Triad display.cpp. What I'll do is I'll walk through some of the key parts of the code here to save us some time. So we have our marker definition. We have a geometry messages point for XYZ information. We also have point stamped, so it's a point plus time, and we have a post stamped position plus orientation. We have some basic math to define things like pi or basic math functions, and we have the core eigen libraries or the basic eigen libraries and TF as well. So one of the first things we're going to do in main is create 3 independent arrow markers for the X, Y, Z axes. So these can be 3 independent objects. We'll call them arrow marker X, Y, and Z. And then we're going to have a function called Init Markers. We'll pass these objects there, and we're going to set up all the basic information. In the header, we set everything to the world frame. And then we set the default position to 000 and the quaternion to 001. We set the type to arrow, action to add, the scale to 0.01, and the color, we're going to have each arrow in different colors. X is red, Y is green, and Z is blue. Later in our service, we'll have a function called, actually we'll use this function a few times in the code, update arrows, where basically the post information is updated for the frame. Again, we will use a service or a client to interact with the marker, and we might be interested in changing the height or the pose of the marker. And so when we call this method update arrows, we will introduce the right pose information for the marker. In our service, we'll have a pose callback method, and the input, the main input to this function is going to be a geometry messages post stamped. So here we have a global variable, global stamp pose. We have a header and a post, and what we're going to do is take that post message, extract the header, and extract the pose. Okay, and then in the method update arrows, we will update the post of the Triad based on the incoming post information from the subscriber callback. So here we have the global pose. We access the post element, then the orientation element, the XYZW of the quaternion, and we copy that to a local quaternion object, as we saw from class a couple of weeks ago, and then convert that to a rotation matrix. The other thing we want to do is use this eigenvector 3D to create the x vector, the y vector, and the z vector. But look at how we're going to do this. It's an interesting way. For the rotation matrix, it's a 3 by 3. The first column represents the x vector, the second column represents the y vector, and the third column represents the z vector. Imagine these are pointing along the x, y, z direction of the world frame. So this would be a 1, 0, 0, this would be a 0, 1, 0, and this would be a 0, 0, 1. That also means that the length of these vectors would be 1 meter. So by creating this variable vec length and setting it to 20 centimeters and multiplying by the vectors, we scale the length of the vectors and then save them like this in this way. So the next thing that we want to do now is place the points for the tips of the arrows. We know the origin, we know the length. Let's set the tip. Okay, so imagine we have this black arrow. Let's say this is going to be the X arrow, and we want to set that tip. We're going to call that the arrow X tip. What we do in the code here on line 52 first is we have an origin from before. This is going to be 0, 0, 0. We just set that equal arrow X tip equal to origin just to get the point structure, so we can access X, Y, Z later. And what we're going to do is say, for the X arrow, we want the X direction to be equal to this vector. Okay? Sorry, this is not a point. This must be vectors. So here, for example, this black arrow, if we project it onto the x-axis, would have a vector along this direction, and then if we projected this onto the y-axis, it would have a vector along this direction, and then we would do the same thing along the z direction. So this x is not necessarily pointing along the world x coordinate frame, so we need to define what's the x position, the y position, and the z position with respect to the world. So from before, we have the arrow marker x, and we can access the points, the x, y, z points, and then we have this other object, the origin and the arrow x tip. Both of these can be pushed back and then save that information right here in arrow marker x into points. We can do the same thing with header, so that we save the world frame into arrow marker x. So in main, we will have a subscription to the Triad pose. So here we will actually not use a service, but a normal publisher. We will publish a post, this node will subscribe to it, and then once we have that post, we will also publish a marker to display the latest marker position. We need to initialize those markers to give them their type and their colors and actions. Then we update the markers on the callback, update the positions or the posts of the markers in the callback, and then we're able to publish each marker individually like this. Publishing arrow marker X, publishing arrow marker Y, publishing arrow marker Z. We still need spin to activate the callback in our node for new poses. So here, just to start our subscription node, we can run example Arvis marker, Triad display, but we will need a publisher which we call the Triad display test node. Okay, and basically when we do that, we'll see something like this. Sorry about that. Let's see. So the publishing test node will be publishing poses that the subscriber receives to change that pose. We have one more example of interactive markers, and this is where a user can use their mouse to move the markers in a linear or rotational fashion. Interactive markers can also let you click on them, for example, a menu, and maybe select something from them. To this end, it's very important to understand the interactive marker message. Here we'll see we need to set the initial pose, the name, the scale, but also set other things like controls and interactive menus. So let's take a look at that. Oh, let's see, I got a little bit lost. Let's separate that. Okay, here it is. So we have a header, we have our pose, we have a name, a description, a scale. If you use menus, you can fill out this information. Then we'll see something called interactive marker controls, where you can have one or more than one. These controls establish the way in which a marker can move. For example, you can move about an axis in a particular direction, linear direction, or you can move about a plane in a two-dimensional space, or you can rotate around a single axis, or you can combine moving across an axis, but also rotate across an axis. You can also have moving in 3 dimensions about a specific point, or you could have moving in any direction without a specific point in the 3 translational axes and the 3 rotational axes. To learn more about these controls, you can come here to the controls tutorial. Okay, and you'll see how this works. Here we have 11 descriptions of ways in which the markers can move. So as part of your homework, I'll ask you to visit this page and try to understand all the different controls that exist. Then we have an orientation. You set the interaction mode as well. We need to say the type of the markers along with their pose, position, and orientation, scale, color, and also if we have an array or not. Okay. For the control, we saw the kinds of controllers that we can use. And so, in summary, the control defines what the marker can do: show a menu, click a button, move an axis, move a plane, rotate an axis, translate in 3D, rotate in 3D with respect to a parent, or rotate and translate in 6D with respect to the origin of the cursor. Okay, and so here's a video where you can see how this is a translation in 60 with respect to the origin of the cursor, and here we can rotate this arm in all kinds of directions. The example for the interactive marker will be here at im_6degreesofreedom.cpp. This is part of the example interactive marker package. And basically, we're going to use a server to set one of two things. We have something called the command mode, and here we can say, hey, tell me, let me tell you what is the desired pose, the desired stand pose for my interactive marker. So here we might say, I want you to go to a new location. That might be a translation or a rotation or both. Or we could also say, tell me what is my current location for the pose. This command mode basically will have one of two values. One is just read the pose, or one is set the pose. If we say read the pose, we just get the current pose back. If we say set the pose, then we'll use this information from IM_desired to move the pose. So this is going to be a service as we have learned before. But there's another thing we need to learn about, which is called an interactive marker server. Within the interactive marker package, there is a API for a special service focused on the interaction between RViz, which is the client, and the actual marker, or the interactive marker, which is going to be the server object. So we're going to be looking at this API in a second, but it's very important you look at it. So here, the server is going to be controlling the pose of the interactive marker. Because once the user clicks on it and moves it, then that marker, whether it's a sphere or a sphere with arrows or a sphere with rings for translation or rotational interactions, needs to move, right? So the server is going to be computing those poses and then sending that through a special service topic called update to RViz, and then receiving any RViz feedback through the feedback topic. Okay, so this is a kind of a new service, but it's dedicated to interactive markers. So to use interactive markers, in this example, there is going to be 4 key steps. Number 1, we're going to have to create a marker, whether it's a single marker or an array of markers. Then we're going to need to define controls. In our example, we're going to have 2. Okay, actually the first control is going to simply contain the markers and nothing else. The second control is going to create arrows for translation and rotation, for both. Then the third step is we're going to create an interactive marker server object. And on this object, we will need to push back the controls. And the controls will already include the markers. So basically, this object has both the controls and the markers. And then, here we have 2 lists. The interactive marker server has a callback where we will process updates from the user. So, which is number 5. And 5, we have the service server object, and this is where we're going to either get or write the marker pose, right? We're going to say, I want this interactive marker to go to a new pose. So then the marker server processes the update from the user. It kind of looks like this. You create, say, the Triad, and then you create controls, okay? And in the control object, which is interactive marker control type, or visualization messages interactive marker control, let's call this IM control. Once we have our markers, we can access the markers element and then push back each marker that we have. So here I just simply call them X, Y, Z. After we have the controls, we will look at the interactive marker object, and what we can do is push one or many controls into its own control structure. So here we have the interactive marker and marker object. This will have a control element, okay, and then we can push back those controls. So here the first one, IM control, just contains the markers. And then after that, we will have 6 more controls. This one, for example, allows translation in the X direction, then in the Y, then in the Z. And then the next 3 allow for rotations in the X, Y, Z directions. So these 7, it's 2 general sets, the holding the markers and then the motion. But these 7 controls are then pushed into the control structure of the interactive marker. Once we do that, we will be working with the interactive marker server API to do a couple of things. Number 1, once we have the interactive marker object, we want to insert it to what is a collection of interactive objects on the server side. After you have inserted the interactive marker, you can call apply changes to reflect the pose of those markers. So here what we're going to do is have the service where the client is telling us a new position for the marker, and then we use this interactive marker server to actually apply the changes. We'll see how that goes in a second. So you can look at this code. Again, let me just open that real quick to help you take a look at it. So we can use raw set, example interactive marker. And here basically we're going to be looking at this IM 6 degree of freedom.cpp. And then later you can also see the client right here. Okay, so right at the top you can see that we have defined the interactive marker server and also this service message that will help us have the command mode and then the request and the response. From that command mode we have these global ints that say get the current pose or set the pose with values of 0 or 1, and we're going to maintain the position and the orientation and the time of that pose with these 3 global variables. 2 more global variables that we have is going to be this interactive marker server object. This comes from interactive marker server class. We're going to call that GIM server. And then we have the feedback as well coming back from our viz. When we go to main, we're going to create 3 objects at the very beginning. Number 1, initialize our ROS node and call it simple marker. Number 2, we're going to create a local interactive marker server object called server, and this will need a topic. Just as we've done in the past, we're going to call this the RT handmaker. So let me show you that. So we're in main, and this is where I create that server interactive marker server object, and I associate it with this interactive marker server topic, RT hand marker. And so something interesting that we do here then is I take the address of this object and copy it into my pointer global interactive marker server. So after this, we're going to just be working with this global variable. Why do we do it? Because we're going to use this server object and the service callback. That service callback is right here at the top, and so it sits outside main. So if we want to be able to use it here, it needs to be global. So this is one way you can do it. You create an object of the same type here, and then later in main you can just create an alias for it right here. The third object that we are, before I go there, we copy the address to the global object, and changes to the markers are published. Sorry, this is RT-hand marker update, not feedback. This is a mistake. And the third object that we create is the service server object. This one is going to be called interactive marker, 6th degree of freedom, interface service. And this will have a topic called interactive marker 6.dov service, and it uses this m6.dov service message service type. Let's take a look. So here's the service server, and here's the service topic, and this is the service callback. Okay, so don't get confused. We have the interactive marker server, and then we have the service server. The service server will be useful to update the desired pose, and then the interactive server will actually implement the changes on RViz. Okay, we initialize a current point for XYZ right here. And what we're going to do next is create the markers, create the controls, pass them to the interactive marker object, and then finally at the end use the API to update those markers into RViz. Okay, and that will access that API through G interactive markers server. So I'm just going to walk you through the code here. We're going to be in main. And the first thing we're going to do is create the interactive marker object. Okay, and so here we initialize it by giving it a name and a frame, and later we're going to add the controls to this. Okay, and so two classes of controls are used. The first one we're going to call IamControl, and it's just going to contain the arrow markers we're going to use. The second class of controls, they don't contain markers. They instead use arrows or rings to move the actual markers. So we'll have 6 of these for translation and rotation. For the arrow markers, we're going to create 3. They're going to form the frame. And so we use the basic marker type, and we call them arrow marker X, Y, and Z. For the interactive marker control, this is the type. The first one is IamControl. And so here we use this function init IamControl, where we provide the control type, the name, and things like that. Once the IamControl has been defined, we can take the interactive marker object, access the control structure, and then push back that interactive marker control. We do the same thing with the other controllers for translation and rotation. So here we have translate control X, Y, Z. And basically this init functions, all that they're defining is in which direction can this control move. So we're going to say move in the X, move in the Y, move in the Z. And for rotation, we're going to give an axis of rotation. Rotate about X, rotate about Y, rotate about Z. Please look at these methods at home. So now that we have these controls created, initialized, we can push them back into the interactive marker as we did with IamControl before. And so at this stage we can use the global interactive marker server object. Okay, and here we have a callback that we're going to call here process feedback, and that's where we're going to use the insert and apply changes. So let's see. Let me open the code at this stage. So let me go to the top. Actually, one sec. Let's look for process feedback. This is going to be one callback, but let me show you how we define it. After we finish adding the controls, we're going to say, let's take this interactive marker server object and let's insert our object. And when we do so, let's do this callback process feedback passed by reference. So this is going to define a behavior for the introduction of these markers, and we'll also need to call apply changes for the changes to actually take place. Now let's look at what we're doing in process feedback. So here we have the interactive marker feedback, and this is the response from Arvis, I believe. So here we get the marker name. Here we get the X, the Y, and the Z positions. So we are posting that. And then, but what we want to do is save that orientation and into the global current quaternion, and then take that position and save it to the global location, and then take that time and save it globally as well. So here we're just getting, what we're actually doing here is saving the latest pose and time of the marker in Arvis. This is the way we do it. We get that pose and time from Arvis here. So that gives us the current pose, right? And that's the discussion here. Interactive markers are limited because they cannot query automatically their current pose. So we must monitor publications when the marker is moved. For example, later when we call the service, we'll change the pose. If we want to get the new pose of the markers, we need to do it through this process feedback callback. And so now we go to the part where we update the pose of the marker. So in main, we created the service server object using this message and using the following callback. Okay, so we'll have a client that posts to this. And from what we mentioned earlier in the callback, we have two modes. The first mode, command mode, would be set to this interactive marker, get current marker pose. And so all we want to do here is just return the pose of the marker. So if request command mode is equal to this, we are going to take the global time, the global point, and the global quaternion, and then copy those over to response, post stamped I am current, post position, post orientation, and return. But if we want to update the pose of the interactive marker, this will be true. And so now we want to update the global positions. So the way we do that is we have this post stamped object, which we call post stamped interactive marker desired. Okay? And so we take the request, which is the new pose, and take that position and orientation and copy that to our global variables. Okay, so we have them here in our global variables. And then we also take that request of post stamped I am desired and save it to a local variable of post stamped I am desired. Once we copy to that local variable, then we copy back again to the response. So now we have saved the new pose here, and the question is, how do I get my interactive marker to actually move? So right here we're going to use the global interactive marker server, and we're going to look at a new method called setPose. Now this is a good time for me to go to the API. I think I probably should have gone earlier, but this is the interactive marker server class reference. And so here there's going to be insert, there's going to be apply changes, and there's going to be setPose. That are some of the main methods we're looking at in this code. So here if we go to setPose, we see that we need to update the pose of a marker with the specified name. And then this change doesn't take effect until you call apply changes. But here we will have a name, a pose, and a header. Okay, so here's the name of the server object topic, and then here is our post stamped I am desired, and then just passing the pose of that, and then calling apply changes. So we can see that here in our service code right above here. Okay, if we have one thing, we just return the current position, but otherwise we set the pose, apply the changes, and return true. So let's see how we can interact in this way. So we'll run ROS core rviz, and then the example interactive marker node. We'll make sure to fix the frame to world. Make sure to add an interactive marker display and set the topic to RTHand marker update. And then we'll see 9 handles, 6 for translation, 3 for rotation. And then what we're going to do is run a service to update the interactive marker pose by 0.1 meters increments in the Z direction. So let me open this window here. So we'll call our actually let's close everything here. Let's start from scratch. ROS core rviz, example interactive marker node. So here we add our interactive marker, expand that, look at the topic. We'll see that we have the right hand marker update. Immediately we get our controls in the X. Sorry, the red is the X, the green is the Y, and the blue is the Z. And when we work with these controls, automatically we're getting an update. So here we can see what the pose is, and if we want to programmatically change this, we can use the client to change the marker pose by 0.1 meters. Okay, so for example here before the pose was XYZ, where the Z was at 0.199, and then after that it's at 0.299. If I, let me see, get a better angle here, we'll see how every time I call this, we'll be moving this marker up. Okay. And if you want to see the client code, we can do that very quickly. This is example IAM client. No. Client test. Service client. And so here, for example, we create the service client with this object name. We provide the type and the service name. Here we set the command mode to get current marker. And then we issue a call with that, and we can get the response position. And after that, we can take that pose, copy to a local object, modify the Z axis by 0.1, and then assign it back to post stamped with a pose and a header. Change the command mode to set new marker pose, and take this local stamped pose and set it to the service message request post stamped IAM desired element, and issue a new client call with that message where we get the response. So you can see that the client is very simple. And that concludes our 3 examples for markers and interactive markers with RViz, and hope you have found it useful. It's more interesting once we start using them in conjunction with robot examples. We'll see some of this in our later lectures in the course. Thank you.